Very good. So we're going to talk about multivariable functions today. Remember that in elementary calculus, you have a function y equals to f of x. In this case, you say that, hey, y depends on x. So y depends on x. Well, what's the meaning of that? It means that x is a free variable. You can choose any number in specific domain. X is a free variable. Based on the definition of functions that you saw before, you can choose x freely, but the value of y depends on the choice of x. And y is dependent variable. Okay. When you have a function in elementary algebra, in calculus, in pre-calculus, you define the domain of that function. The domain of the function is the set of all x values. Okay. But mathematically, we write it this way. It's that d for the domain is equal to the set of, so this is the set of x values such that with the condition that x satisfies some conditions. X satisfies some conditions. As to define the domain of the function, to define the range of the function, the y values. After specifying what are x, we move and talk about the range of the function. So the range is the set of y values or output values. When it comes to the range, we're working with vertical lines, y values. So we're going to say that, hey, the range is the set of y values such that y is related to x from the domain. Related to x. So note that here we only have one free variable. Okay. When you try to graph this function is defined in x, y plane. It has some curve representing the graph of this function, whatever it is. Now, generalize the idea and add more free variables. So let's generalize the idea. This is just one variable function, right? Now we are interested in adding a new variable. So definition of a two-variable function. So now we're introducing three variables. Let define the two free variables. Okay. We can take a machine like F, like G, like H, combine these together and create something new. The function, new function, Z equals to F of X and Y is actually called a two-variable function. Called a two-variable function. Well, how? It's easy. Here you have a machine like F. Instead of having just one free variable, you have a choice for two variables. You plug in an ordered pair like X and Y into this machine. This machine makes some adjustments, makes some changes or not to these two, and then it has some output value like 0. So input value, input is a point, and the output is one number. You might have two values or more values, but these are just numerical values. Just note that the input value is a point. It must be in terms of X, Y, and the output value is going to be on Z axis. Okay. That's the definition of a two-variable function. What's the definition of domain and range? The domain of the function is equal to, remember that, you're using set user notation. Here we have this set of all X, Y's. The input values are ordered pairs, X and Y, such that, well, here X and Y are satisfying some conditions. So this is the domain, X and Y. The domain is part of the plane. Domain is a subset of plane. Okay. What about the range? Range, part of Z axis. The range, in this case, is going to be the set of all Z values, numerical values, such that Z is related to X and Y that you defined in the domain part